4. Who else wanted to see number 4? Okay. What other ones did we have? Keela? 3. Who else wanted to see number 3? A couple of us. Okay. So we could do 3 and we'll do 4, and then the others we won't do. So as I mentioned when we first started this, as you start getting more of these, I want you to collaborate with each other, talk to each other. How do you get this? What did you get for this one? Do your work and answer on the answer sheet, and then after we've done 5, I'm going to have you turn that in. I'm going to check over all of them, drop the lowest one, and then grade it and give it back to you. It'll be informative. What did we say? 3 and 4. So for number 3, we have to simplify. So we need to do what first? Distribute. The 8 here, and there's a negative 1 here. So this should be 6 plus, multiply these to get 32x, multiply these to get negative 56, negative 2x, and negative 1. And then start to combine your like terms. Here we have 32x, negative 2x, and then all of your constants. So 32 minus 2 would give us 30. 6 minus 56 would be negative 50. Negative 50 minus 1 would be negative 50. So 30x minus 51 should be our final answer there. What questions do we have on that? If you didn't get that, make sure you get that now. For number 4, we had to evaluate, put both x and y back in. So even though we are no longer covering this, these are things we still have to keep in mind throughout the year. So we're going to put in a negative 3 and a positive 4. Use your parentheses or a dot. Do what's inside first. So we have a positive 12. This will become a positive 15. Add those two together to get 27. And then there's nothing else left to do inside. So you would drop your absolute value bars, but we have a negative here, so this would become a negative 27. Questions on that one? What was your question? We're not going over any others. For number 2, I don't remember what it was for. Negative 16. Alright. So make sure you have at least those answers. If you have time, maybe later today or later on Tuesday, check with others on the answers you have for the other problems. You have a few things on your desk. One is a little blue exponent review book. That is for your usage whenever you so choose throughout this unit. If you need extra practice, because you get it and you just want more practice, because you don't get it and you feel like more practice could help, either or. That is your book to use whenever you so choose. That will be something I look for when we do binder checks, so make sure you have it. If you look on your calendar, there is one thing I want to point out, one thing we need to fix. So the one thing we need to fix, Wednesday, 10:12, I probably will not see you at all that day because it's a PSAT day. So everything on that day will get moved to the next day. Tuesday, 10/18 will stay the same. So your test day will be one day later, except I would normally see you the following Monday after that, which would be October 31st. But you guys don't have school that day, so it would be Tuesday, November 1st. So keep that in mind. I'll put those dates in Canvas. I have to update those because I forgot about the PSAT day. On 10/18, so you'll see that we have 2 flex days in October. We should have had 2 in September, but we didn't get to that. So we'll have 1 next Tuesday, then we'll have 1 on the 18th. The 1 on the 18th, if you wanted to retake Unit 1, retake Unit 2, that's when you're going to retake it. If you don't have your retake work done by then you have to come after school that week, because the deadline will be that week, or maybe it'll be that following Tuesday, because the quarter ends the 31st. Questions on anything I just said? Right, so if you have not finished your retake stuff for Unit 1, on Tuesday you'll have that option, but you may also need to do retake stuff for Unit 2. I finished grading them, I just haven't put them in yet, so I'll be doing that this weekend. Right. So last unit we talked about simplifying radicals and all of those things. This unit is going to be about exponents and polynomials, exponent rules, kind of going into when we were multiplying radicals and we had exponents, why we added the exponents, things like that. We're going to talk about all those things. And then some actual polynomial rules and classifications and stuff like that. Okay. So I'm going to pull this part down so you can pull this in. And then I'm going to read it. So polynomials, the definition for that is an expression consisting of many terms. And when we talk about standard form for polynomials, it must be written in alphabetical order with the highest exponents first. So if it's just one variable, it's highest exponents first to lowest exponents. If there's multiple variables, bless you, not connected, it would be ABC order, highest exponent, combined. You'll see what that means here in a second. So like in this example, there's only one variable, so it goes highest exponent to none. We'll talk about the actual exponents of the 4x and the 7 here in a minute. Highest exponent is called the degree. So this 3, we're going to name what that degree is actually called. When we classify polynomials, they are classified by the degree and the number of terms. So you should have that table. So the degree is the actual exponent itself. So for this example, this would be a cubic function because the highest exponent is 3. But there are 4 terms, so since there are 4 terms, this is a polynomial. These can get mixed up a lot. If I just had 7, 7 doesn't have an exponent, so the degree would be a constant, which we've heard that term before. But because it's only one term, that would be a monomial. And you can keep going on and on and on with those. Okay, questions on this so far? We're going to use this table to classify some polynomials, as well as put them in standard form. This has an exponent of 1, so that would be a linear, anything with just x, not x to a higher exponent. Okay. So for number 1, what is the degree of this? Think about the exponent. Does it have 1? It's constant because it doesn't have 1. If you want to put next to it, exponent is 0 so that you know that's why it's constant. To help you remember that, you can do that. Now we need to determine the number of terms. So there's just one thing here. So that would be monomial. It may help you if you know what the prefixes mean. Also, mono means 1, bino means 2, tri, and mon means 1, 2, and 3, where poly means multiple. So for negative 2x, what would the degree of that one be? Linear. So this has an exponent of 1. You just don't see it. So this would be linear. Anything with an x that doesn't have an exponent, well, it has one, it's just 1, is linear. Well, what is the number of terms? 1. So it's monomial again. Now what about number 3? What is the degree of that one? It's linear again. We're looking at both of these. The highest exponent would be this one, because this one doesn't have 1, and this one has 1, we just don't see it. So again, it would be linear. How many terms do we have?
2.
2, so that would make it a binomial. Number 4. What is the degree? Quadratic, because we have it squared. I feel like the ones with exponents are easier to see. How many terms do we have?
2. So it's binomial.
Do we have only 2?
3.
3. Trinomial. There we go. Number 5, the degree. Cubic. To the 3rd power is a cubic function. And number of terms.
Binomial.
Say that again.
Binomial.
Binomial, because we have 2. Yes. Okay. And the last one. What is the degree? 7. So not the number in front, but the highest exponent.
Oh, 4. So it's
Quartic. This is the 4. When you go on to algebra 2, you learn quantic and whatever 6 is.
And it's a polynomial.
This is a polynomial because it has 4 or more. Okay. So you will need to know those terms, memorize them, know what they mean. This is one objective, polynomial classification. Questions so far? The second part of this is, can we take these and put it in standard form? So in alphabetic order, highest exponent goes first. So for this one, which one would go first?
2x.
2x squared. And then
3x.
And then 3x.
And then 1.
And then 1. So So we want it in decreasing exponent order. For number 8, which one will go first? 7x cubed. And then x squared. And then negative x. And then our 64. So whatever the sign is, we have to also bring that over. If we end up switching the sign, then we've changed the problem. Right. Number 9, what will go first?
x3.
X to the third.
And then 5x to the second power. And then negative x. And then
Sometimes these will trick you. Sometimes they'll have like x to the third and then x and then a constant, or x to the fourth and then x squared and then a constant, or whatever. Sometimes they won't have every single number. It's still whatever would come next. Whatever is the lowest next. All right, number 10, what would go first? And then
x.
and then x, and then 20. Right. With this one, 11, we have A's and B's. So the order in this has to be alphabetical. So the A to the third will go first because it's by itself. Then we have AB. We want the next highest, or the decreasing order, exponent of A. So 5A squared, B squared. Then our 2AB, because we're still decreasing in exponent of A. Then at the end, we have B by itself, so that would go at the end. That's where it gets a little confusing, because you see the 3 with the B, and you would have put that first, but it still has to be in ABC order. Questions about that so far? For 12, what would go first?
X to the third, or negative x to the third.
Negative x to the third.
And then it would be negative 7x2, y2. And then it would be 5y to the third, and then 13.
So always think about your ABC order first, and then your exponents if there are multiple. Now, if there are none that are like x, y, and it's just x and then y, then you would put x to the third, y to the third, constant, whatever else. How do we feel about putting things in standard order / polynomial classification? Good, okay, not good, I don't understand. I see some thumbs, I don't see everyone's. Okay. There is, it may not be in this packet. If you want more practice on this, the Khan Academy will be good practice, as well as there's a Delta Math related to this. If you have not ever joined Delta Math, you could do that. Okay. The next part is your second objective, or part of it, because there's a lot of exponent rules, so we're just going to talk about 2 of them today. But first we're going to go back to some things. If we have negative bases, so I don't think I have this on here, but if I had a power, let me go back here. The 13 would be your base, the 3 would be your exponent or your power. So if I have negative bases raised to an even power, this will always be positive, but we have to use parentheses. So an example, anytime we have a negative number and we square it, and then we end up with a positive, because we're thinking, really, this is -2 times -2, which is why it becomes positive. If we don't use the parentheses, we've talked about this before, we end up with a negative times a positive, which gives us a negative, making it wrong. So we have to keep in mind to use parentheses if we have negative bases. The opposite is true for odd exponents, odd powers, because those will always be negative no matter what. So if I use parentheses, let's say I had negative 2 raised to the third, that would be negative 2 times negative 2 times negative 2. The first two would make it positive, but that last one would make it negative. If I didn't use parentheses, it would be similar to this, and I would, again, have a negative. So the parentheses for odd powers doesn't matter, but even we have to use parentheses. Now, we're going to talk about negative exponents and how their rule is different. Anyone still need that before I read them? Okay. If I asked you what's, and I just had it up here so you probably already saw it, what 0 squared was, you would tell me what? 0. And I'm going to expand this just so we kind of see what this is. But that would be 0 times 0, which would give us 0. 1 squared would be 1. And we know that's 1 times 1, which would just give us 1. 2 squared, 4. And 3 squared. Now, when we have negative exponents, math magic happens. We take whatever this base is, we flip it, and raise it to a positive exponent. So this would become 1 over 0 raised to the second power. We know 0 to the second power is 0. So we have something like this. But put 1 over 0 in your calculator. What happens? Yeah, there's an error in this class. Basically, until you get to pre-calc/calculus, we can't divide by 0. It's undefined. We just don't mess with that. Same thing for the 1. We're going to take it. All of these numbers have individual or invisible 1s underneath, like they're fractions. So when I take it and I flip it, I still have 1 over 1. We know 1 squared is still 1. So this doesn't really change what it already was. Where you really see that change is with other numbers. So if I take this and I flip it, it becomes now 1 over 2 squared. And we know 2 squared is 4. So it's really like I took this and flipped it. Took the end result of 2 squared and flipped it. So all of these answers, if you have numbers, are going to be fractions. So what do we think 3 to the negative 2 would be? 1/9. So the rule, and it says it right here, is anytime you have something raised to a negative exponent, you take it, imagine it's over 1, you take it and flip it, and raise it to a positive exponent, always. But what if we have just variables and not exponents? Same thing happens, it just looks different. So here, if I were to write out a squared, that would be a times a. But I don't know what a is, so I'm just going to combine it back. And I could do that same thing for all of these. This would be x times x times x. This would be just d. this would be y times y times y times y times y. So you can write that if you want, you don't have to. But now if I have a to the negative 2, all of your variables also have a 1 underneath. So I'm going to take it and flip it. Jada?
It's just 1 over a squared.
Mm-hmm. What about x to the negative 3rd? Jada, go.
Same.
What would it be?
1 over x squared. That's cubed.
Cube. Mm-hmm. D to the negative 1st. 1 over d. Virginia, you can see the last one.
1 over 0 to the power of 5.
Now, for the 1 over d, you can put 1 over d to the 1st, but the 1 is not necessary. So anytime you have a negative exponent, you're going to take it and flip it. This was not on here, but I am going to show you what happens if it's opposite. Because sometimes you get this and you just flip it. But if you had like 1 over a to the negative 2, it's already in the bottom. So when you flip it, you're just going to move it back. So they're inverses. If it's already in the bottom, you move it to the top. If it was in the top or in the numerator, you would move it to the bottom, and vice versa. Questions so far? So that's negative exponents. And we're going to talk about 0 exponents. So go on to the next page if you haven't already. Before you write this down, I'm just going to kind of talk through the pattern of this table, and then we'll talk about 0 exponents and what they really mean. So the general rule for 0 exponents is if you raise anything to a 0 power, you get 1. So let's test that really fast. Pick a number, whatever number you want. Raise it to the power of 0. So you can use your caret to raise it to the power of 0. What did you get? Unless you put in a negative number, you should have all gotten 1. If you put in a negative, you would have gotten negative 1, but same thing. So this is to see what happens, or would the same thing happen for 0, what happens with our 0. So if I had 2 to some exponent, I have 2 to the 3rd is 8, 2 squared is 4, like we know these numbers. Each time, I'm really dividing by 2. So if I divided by 2 here, it would make sense that 2 to the 0 is 1. And I could apply this all the way through. If I have 10 to the 3rd, that's 1,000. 10 squared is 100. 10 to the 1st is 10. Each time, I'm really dividing by 10. So if I divided by 10 again, I would get 1. Same thing here, even though this is negative. I'm dividing by negative 3 each time. But with the zeros is weird, because 0 to the 3rd is 0. 0 squared is 0. 0 to the 1st is 0. So 0 to the 1st should also be 0, but 0 to anything is 1. It can't be both. So then we look at it a different way. If all of these things should be 1, but it should also be 0, if you put in 0 to the 0, so go ahead and do that. 0 to the 0, nope. What happens? You get another error. So any number except 0, when you put in 0 as an exponent, you get 1. Unless it's a negative. So I do want you to write this down. Negative bases raised to the 0 power, if parentheses aren't used, will be negative 1. But besides that, everything else will be 1. So you have two choices, 1 or -1. So if I said, what is 1,000,000 raised to the 0 power? 1. What if I said infinity raised to the 0 power? Still 1. The answer is not going to change. Even if I started making up things like apple to the 0 power, it's still 1. No matter what, it's still 1. Unless it was a negative. Anyone still need this? Okay. So someone tell me, what is 5 to the 0? 1. What about -2 to the 0? 1. 1.02 to the 0? 1. 1/3 to the 0? 1. So none of that matters. It's always going to be 1, no matter what. As long as you use parentheses if you have negatives. If you want this rule, I know it said it on the previous page, but this is the rule for that. Any base to the power of 0 equals 1. If you want to put like asterisk, unless it's a negative without parentheses. We're going to try some negative examples, and then you'll have time to practice. Okay. For number 1 in the negative exponent section, we have 4y(x to the -3rd). Is everything being raised to the -3rd? No. What all is being raised to the -3rd? Just x. So that is the only thing that's going to change. So we would write this as 4y. Everything's really multiplying because they're all next to one another. How would we rewrite x to the -3rd?
1/x cubed.
The very last thing we have to do, and as you start to get better at this, you can do this kind of all at one step, is we have to combine everything into one fraction. Remember that these are all over 1. So these would all go in our numerator. This would stay in our denominator. We get 4y over x to the 3rd. Do we have any questions about that before we continue? Four to the -3rd would be what?
1/64.
Okay. So I'm going to do it in steps. It would be 1 over 4 to the 3rd, and then we would have to figure out what 4 to the 3rd is, which is 64. So when we get into more exponent rules, if you have exponents like that, we still need to simplify. This is an example, like I said earlier. We have 1 over w to the -4. How would we rewrite that? We just flip it. The base is really 1 over w, so if we flip that and make it positive, it would just be w to the 4th. Let's do 6, and then if you want to see 4 and 5, if we have time to do that. So for number 6, we have x, we have y, we have 3, 4, z, we have a bunch of things going on. Simplify what you can. You can leave the simplification to the end, but I would say go ahead and move the y and the 3 first. So right now we have 4 to the third, x to the third. Y squared would get moved to the bottom, to the denominator. 3 squared would get moved to the numerator. So they would like change places. Oops, and I forgot about z. Z would also get moved to the numerator. So that's just dealing with the negative exponents. Then we still have to simplify. 4 to the third we just did was 64. I'm going to move this number in front. 3 squared we know is 9. This needs to be in ABC order. So the last thing we have to do is multiply. 64 and 9. Someone do that. Tell me what you get. 576. Yeah. This unit you will have your calculator because these numbers can get big really fast. Questions on that, Regina?
Why is the 3 on top?
Because it was in the denominator, but it had a negative exponent. So kind of like this one, we moved it to the numerator because this is really over 1. We did the same thing here. Move the 3 up, move the z up, move the y down. Switched everything. Would we like to see 4 or 5? 4. Okay. Number 4. What can be changed? The s. We can also change the 7 squared, but we'll do that later. So if we rewrite this, s is going to get moved to the denominator because it has a negative. So you have 7 squared t squared over s to the 4th. And then our last step would be to actually multiply or do 7 squared. My s's kind of look like 5s, but that is an s. Trying to make it look more like an s. I don't know if that works. Okay. I'm going to pick a couple practice problems that I want you to try. On the next page, I think it's the next page. I'm going to pick a lot more than usual because you could do these relatively quickly. 1, 6, 9, 10, 15. So from the top section. 1, 6, 9, 10, 15. 46. 49. Okay, so try those. I'll be around if you have questions, need me to check it. If you finish before 53, I can